When we do a titration, we usually see a very distinct change in the color at the endpoint, at the equivalence point. So we're going to try to make the endpoint match with the equivalence point. So our eyes are only able to identify the distinct color of one form of the indicator when the ratio of its concentration to the dissociated form of the indicator is about 10:1. So one form of the undissociated indicator, and this is the dissociated form of the indicator, when the ratio is 10:1, when the concentration of the ratio is 10:1, this is only when you see the change in color. So there is a dramatic change in color. So when this changes to 1:10, only you will see the color change. So here you have a 10-fold change in pH, in concentration. And here as well, you have a 10-fold change in concentration. So because you have 2 times 10-fold change in concentration, so this represents a change of 2 pH units. So 10-fold change in concentration, this represents 1 pH unit. 10-fold change in concentration, this represents 1 pH unit. So overall, you have 2 pH units change in the range of endpoint that our eyes can be able to identify the color change. So this is why we say that there is a range of plus minus 1 pH or pKa units at which the eye can definitely notice the color change. So this is why if the pKa value is, let's say, 6, then our eye will be able to see the endpoint in the range of 5 to 7. So this is why you see that pH range, which is approximately plus minus 1 value to the pKa value. So this is the pH range that our eye will be able to see the color change.